Measurement is perhaps the most important topic that we'll be covering in this class. We know what it means to measure. It means to assess something in the observable or natural universe. If we want to know how tall a person is, we know that we get out a measuring stick. We know if we want to know how much someone weighs, we use a scale. But what if we need to measure how happy someone is, how charismatic, how engaging? This is really where we see the split between the natural and the social sciences. Although scientists from both camps believe that we exist in a universe that is governed by laws, and that laws ultimately predict the phenomena we study, the natural scientists are several thousand years ahead of the social scientists in terms of developing valid ways to measure those phenomena they're interested in studying. What does the measurement look like in the social sciences? Well, here's an example of one that you've seen before, the perceived immediacy measure. Again, perceived immediacy is the perceived amount of psychological closeness one person feels to another. Look at the items. Here we're assessing on a scale of 1 to 7 whether you feel that the person you're thinking of is cold or warm, comforting or uncomforting, responsive, unresponsive, personable, disagreeable, and so forth. Now, ideally, we would be able to take out one tool and using simply one indicator, like a ruler or a scale, and identify how immediate one person perceives another to be. But we don't have measurements that sophisticated yet in the social sciences. So instead, we use multiple items and try to use a combination of items to get closer and closer to observing the phenomenon we're interested in. This particular type of measure is called a semantic differential. Semantics are words. Differentials are differences. So, a semantic differential is a type of measure in which you use semantic opposites to get someone to align their feelings about a particular concept. Semantic differentials are one of the 3 most popular types of measurements used in the social sciences. Another popular type is the Likert type item scale. You've seen many Likert type items before. You'll see a statement such as, "I like ice cream," and then be asked to respond on a scale of usually 1 to 7 how much you disagree or agree with that item. The next popular type of measure we use in the social sciences is a thermometer scale, also sometimes called a ladder scale. This type of measure assesses through pictorial representations of feelings and thoughts. Thermometer type scales are particularly useful when you're dealing with someone who is cognitively limited. For example, if you take a child to the hospital because their stomach hurts, they may not have the vocabulary to explain well how they feel, but they can probably find a face on a chart that represents how they feel. Likewise, if you go in an extreme amount of pain, you may not be able to fully articulate, despite your age and your normal vocabulary, how you feel, but the pictures will help. This is why thermometer type scales are so popular in medical settings. So how do you know when you've developed a measure, whether it's actually assessing what you're interested in? How do you know that it's going to do it well? When you ask these questions, you're really asking, how do I know that a measurement is valid? How do I know it's reliable? Validity asks, how do I know that a measure is assessing one construct and one construct only, and it's assessing the construct I'm interested in? A good analogy of validity can be seen in an old film camera. Now, for those of you who are too young to have ever seen one of these cameras, humor me for a moment as I explain how they work. When you use one of these old film cameras, you would physically roll film through it so that there was a blank piece of film ready to have a photograph taken on top of it whenever you open the shutters. After you took your picture, you would then manually roll the photo you've just taken away so that there was another blank piece of film ready to take a photo. And then you'd roll that piece away and take another photo. But sometimes the camera would malfunction. And when you thought you were rolling your new picture away, it would actually be stuck, and you'd end up taking another picture directly on top of it. When that happened, you get something that looks like this. Do you see the boy in blue there? Do you see that there's a horizontal picture of him in the lower left-hand corner playing cards? But there's also a picture of the same boy vertically standing beside a buffet of food. In a measurement perspective, we would say that this is an invalid picture, because there's not one and only one image being captured, assessed in the photograph. By the time we ask whether or not a measure is reliable, we've already ascertained that it's indeed valid. Because why would you care how clear your measure is, how accurately it's assessing something, if you don't know what it's actually assessing? So again, validity is concerned with what you're assessing with the measure, and reliability is concerned with how well and how consistently it will assess that contract across multiple samples. Because you have a background in reliability from your statistics course, let's focus on validity. There are several ways to test the validity of a measure. The first is simply face validity, and it is truly the weakest of all the tests. Face validity relies on your own judgment. It involves you looking at a measure after it's been created and using common sense to determine whether or not it actually appears to be an effective measure. The second type of validity is content validity. Content validity looks at the statistical soundness of a measurement. Now, the stats involved in testing the content validity of a measure are far beyond what you'd be required to know for this class. But look at this measurement model for perceived immediacy. Up at the top of the picture, you have the construct that is perceived immediacy. And we are claiming that perceived immediacy is being captured or manifested in the 9 items that you looked at on the semantic differential earlier. But we also know that for each of those items, there's a certain amount of error acting upon them. This error can be accounted for by participants not paying attention to what they're doing, or it could be issues with the measure itself, such as confusing wording or wording that takes on different meaning as it moves across cultural groups. When we develop items for a measure, we want to make sure that each item is stronger than the error that could be acting upon it. We use confirmatory factor analyses to confirm a measurement model. Here's something that should look familiar to you. Do you recognize this formula from your statistics class? This is the formula that is used to identify how many unique correlations exist in a sample. To perform a confirmatory factor analysis, you need more unique correlations between items than items themselves, so that you have correlations left over to test the fit of the items to the construct they're reflecting. So how many items at minimum do you need to test the content validity? Let's try to figure it out. If I have one item, 1 squared is 1, minus 1 is 0, divided by 2 is 0. So if you have one item, you have no unique correlations. How about if I have 2? 2 squared is 4, minus 2 is 2, divided by 2 is 1. So if I have 2 items, I have 1 correlation between them. How about 3? 3 squared is 9, minus 3 is 6, divided by 2 is 3. If I have 3 items, I have 3 unique correlations. How about 4? 4 squared is 16, minus 4 is 12, divided by 2 is 6. All right, finally, with 4, we have more unique correlations than we do items, so we can actually do a content validity test. If you take nothing away from what I've just said about content validity, take this. To test the validity of a measure, it must have at least 4 items. If you are developing a measure, you want to develop more than 4 items to test. That way, if you have any bad items, you can remove them and still have a measurement left. 4 is the minimum number of items that you need to have when you're done developing your measure. The next type of validity is predictive validity. Predictive validity asks how well a person's score on your measure can predict their score on a different measure. Take, for example, someone's health information seeking behaviors. If someone has high health information behaviors, is very well versed in health information, then theoretically, they should also engage in a lot of preventative health care. So if I develop a measure of health information behaviors, I should be able to use that measure to predict a person's preventative health care behaviors. If so, then I have predictive validity for my measure. The next type is convergent validity. Convergent validity looks at how well a measure matches another measure in which it should be theoretically related. We often use this to improve our measures. For example, if I have a measure of health information behavior, but I know it has some problems, and I develop a new one, these 2 measures that are theoretically supposed to be assessing the exact same thing should be highly correlated. If so, my new measure shows convergent validity. Concurrent validity deals with how sensitive a measure is. Let's use our same example of health information behaviors. If I have developed a valid measure of health information behaviors, it should be sensitive enough to allow me to identify different groups of participants without me having to look up their demographic information. For example, we know that it is very, very rare for a person to look up information about a type of cancer unless that type of cancer has become salient to them. And by salient, I mean whether they or someone that is very close to them has that illness. So if I've developed a measure to assess someone's health behaviors about a type of cancer, by looking at the scores of participants, how high those information behaviors are, whether they're really seeking or not at all, I should be able to determine whether or not that illness is salient to them. Last, we have discriminant validity. Discriminant validity asks whether or not a measure has a relationship with something that it should theoretically have no relationship with. For example, if I distribute my new health information behavior measure to an adult sample and find that their health information behaviors are highly correlated with their height, something is wrong. How tall a person is should not predict their health information seeking behaviors. So because of that, I would know that there was probably something wrong with my measure. When someone develops a new measure for the social sciences, part of that involves developing a validity portfolio, which shows that their new measure has face, content, predictive, convergent, concurrent, and discriminant validity. The more types of validity that can be established for the measure, the more confidence we have that it's a valid measure.